Hello, my name is Anthony Mazzaro, and this is my presentation on lightweight construction and its effects on the modern fire service. So, before we get started, let's talk about the fire service in general. Let's clarify what's our purpose. What do? We save lives, we save property, we protect the community. How do we save lives? We search buildings for people that are trapped, we pull them out of those buildings, and we get them to medical care. We save property. How do we do that? We put water on fire, we ensure that new property isn't consumed by fire, and we remove property before it's able to be damaged. And we protect the community. We do that by extinguishing buildings that are on fire. One building on fire is a bad day for a family. A block on fire is a bad day for a community. A business on fire is a bad day for the entire neighborhood, so on and so forth. So, how do we do it? We extinguish fires. We put water on fire. We put an extinguishing agent on the fire, and we stop the damage that's taking place. We search buildings. We crawl into buildings. We find people that are trapped. We remove them from those buildings. We overhaul structures. We take down walls. We take down windows. We find hidden fires so that we can stop the burning process and bring the community back to its base. We protect exposures. We ensure that your neighbor's house doesn't burn down just because your house is on fire. And we salvage property. We remove undamaged property from the building to ensure that the property itself does not become more damaged. So now that we have that clarified, let's talk about building construction. This is a quick overview of building construction. So from the 1800s to the 1940s, we used what we call traditional construction techniques. This had dimensional lumber. What is dimensional lumber? It's when you say a 2x4, that board is 2 inches by 4 inches by however long you need it to be. So it's the true dimensions that is stated on the piece of lumber. Usually this is associated with larger lumber, 4x4s, 8x8, 16x16, so on and so forth. The point is that you had thick, large pieces of lumber. These buildings had a lot of brick and mortar in them. Sometimes it was a structural element, sometimes it was a facade. Most houses use brick and mortar as a facade on the outside of the structure. So you would have dimensional lumber interior, brick and mortar on the outside. But some of your older downtown style buildings, industrial buildings, were brick and mortar for structural elements of the building. And this is exactly what it sounds like. Brick, mortar stacked on top of each other, compressive weight of the building would compress the bricks. Balloon frame construction. You see a good example of balloon frame construction in the small house below you. For those of you that don't know, balloon frame construction means that the lumber for the walls would run from the top plate or the roof plate of the building all the way down to the foundation point for the building. They were a single large piece of lumber that was constructed and tilted up. So around the 1940s, we had to change the way we did construction. Why did we have to change? Because you could not get enough long pieces of lumber to build houses at the rate we needed them. So essentially, if I had a 3-story house, I had to have a 30-foot long piece of 2x4 to construct a wall. It was difficult to find that much lumber in that short of a time. So we changed the way we built buildings. We moved to a platform frame, which meant that each floor was built on top of one another. We moved to engineered lumber. So 2x4 wasn't actually 2x4 anymore. Nowadays, you walk into the Home Depot and you buy a 2x4, which you're actually buying is a piece of lumber that is 1.5 inches by 3.5 inches. So we cut down on the amount of wood in a piece of wood. How do we make up for that? We reoriented the way that we place that wood. So you lose strength in lumber when you reduce the amount of material. But if you lay that same piece of material out in a triangle, like trusses are constructed, that piece of lumber now has more strength. It's using engineering to replace material. On top of that, we started using gusset plates. Why? Because it was very labor intensive to take these massive trusses that we were now using to hold up ceilings and have to run screws and nails into them. So gusset plates are what you can see in the picture below. It's these large piece of metal with about a 1/4-inch metal piece sticking out of it. You hammer it into 2 pieces of lumber. It holds the 2 together. We also moved to glue laminated lumber. This was a change from that was also corresponded with the difficulty in getting wood. Glue laminated lumber is when I take pieces of wood, lay them down in a sheet, put glue across the whole thing to hold it together, compress it, heat it, do it over and over again. What do you get at the end of that process? You get plywood. You get large sheets of plywood that we use for decking and facing and things like that. Once upon a time, that was all tongue and groove wood that you'd have to lay down plank by plank by plank. It was a lot faster and cheaper to make these large pieces that we can lay down. So that's what the difference between modern and traditional construction is. So let's talk about how that changes when a building catches on fire. In traditional construction, we had large, thick pieces of wood. When a piece of wood burns, as it loses material, it loses strength. So since I had dimensional lumber that had more material to it, it could be on fire for longer before it lost its strength. Fire would spread in these buildings through the openings. I talked about how we leaned these walls up and we had a vertical channel that ran from the top to the bottom of the structure. The fire, if it could get behind the walls, would follow those channels and spread throughout the building. Buildings could stand after heavy structural damage because there was so much lumber in these buildings. The loss of one 2x4 was not catastrophic for the building. The loss of any single piece in the building would be fine. It would stand. You would see more local collapses. Small pieces of floor that had been damaged by fire would fall through, but the whole structure would hold. And the contents of these buildings are more flammable than the structure themselves. The reality is, thick pieces of material do not burn well. Things have to be broken down into a small gaseous state to catch on fire. Big pieces of lumber, they don't burn. Modern construction, these collapse quickly. Why? Because we build things as a system. We talked about how we made up for our loss of material by creating a system to create strength in that building. And that system works fantastic when it's in normal conditions. We don't operate in normal conditions. Things are on fire. What happens when you heat up metal? It expands. We talked about gusset plates. When gusset plates expand, they pop out of those trusses. When those gusset plates are removed, there's nothing holding that wood together anymore. So when those gusset plates pop, the truss collapses, everything falls in. Because all of these buildings are built as a system, when any part of a system fails, the system fails. So in older construction, we would see a small piece of floor fall through where a floor joist had failed. In modern construction, lightweight construction, when a piece of the flooring fails, the entire system fails and the whole floor comes down. Pure numbers here. In an old building, we would see anywhere between 15 and 30 minutes until we could expect a floor collapse. In modern construction, when flame directly impinges the structural elements of the building, 4 to 6 minutes, that building collapses. And what's the upside of modern construction? They're compartmentalized. We had to get rid of those tall vertical structures. We had to get rid of those openings in construction. So we compartmentalize these buildings so that each floor doesn't interconnect. A lot of times, even each half of the house won't interconnect. That's a good thing for us. It holds the fire in one spot. But these buildings collapsed suddenly and with very little warning. In an old building, we had lots and lots of warning signs. Brick and mortar would pop, bricks would fall out, buildings would groan, floors would sag and creak. There was a lot of signs that building was coming down. But in this modern construction, like I said, one small piece can cause the cascading element to cause the whole thing to collapse. You don't hear a gusset plate fall when a building's on fire, but you will hear all of the wood suddenly hitting the ground along with you in it. And the structures contribute to the fire load. I talked about how we'd have glue laminated wood. Glue is incredibly flammable. I talked about how large pieces of lumber have to be broken down into small pieces of lumber. Well, when you have plywood, it's already in small pieces of lumber. So when that glue burns, all of those small pieces of wood catch fire. The actual structure itself contributes to the fire load. So let's talk about how we have discussed moving forward in this lightweight construction. It's undeniable that our buildings are different. Yes, those old buildings are still present, but a lot of us live and work in communities that are mostly modern construction, built since the 1940s. Various stages of lightweight construction. It's an important thing to remember. Not every modern building has full-bore lightweight construction. These changes happened over time. Buildings have various levels of lightweight construction. But the traditionalist method, this is your old school individual in the fire department who has probably been around for 20 years, just overgeneralizing. Many people hold this view. It is that the mission hasn't changed and neither should we. Essentially saying our mission is still to protect lives, protect property. Doesn't matter what changes about the building, that's the mission, that's what we accomplish. Interior attack is the best way to accomplish our mission. Essentially saying the only way we can do our job is if we go inside of these buildings. And danger is part of the job. It is inherently, right? We're firemen. Danger is a part of our job. But how much danger? There are problems with this. I would hope some of you are picking them out. The mission hasn't changed, neither should we. That is correct. The mission hasn't changed, but the battlefield that we fight it on has dramatically changed. If you were a soldier going to war and you planned to go fight that war in a desert and you suddenly showed up and it was a naval combat, do you think you should change your tactics? Yeah, that would make a lot of sense. Interior attack is the best way to accomplish our mission. I am with these people on this. The interior attack is the best way to accomplish our mission. We'll discuss this a little more later. Danger is a part of our job. That is correct. Danger is a part of our job, but no one signs up for any job guaranteeing your death. Our job is to risk our lives to save others, not guarantee our death and ensure that we don't change anything. Danger is part of our job. Controlled risk is also part of our job. We have families at home. We have communities that rely on us. A dead fireman doesn't put out the next fire. Let that sink in. There's a safety approach. This is the complete other side of everything. They are going to argue that lightweight construction is unpredictable and dangerous. They're going to argue that fires can be extinguished from the outside and should be before we enter these buildings because, point one, lightweight construction is dangerous and unpredictable. And they're going to argue we didn't cause the problem, we shouldn't become part of it. Also, has some serious flaws that I hope you're all seeing. Lightweight construction is unpredictable and dangerous. That is factually incorrect. Lightweight construction is just as predictable as traditional construction. It's just quick. But again, we'll talk about this on the next slide. Fires can be extinguished from the exterior and should be before entering. Correct, some fires can be extinguished from the exterior, but we talked about overhaul earlier. How do I open up a building from the outside? I can't. I'm just knocking down the building. How can I search for people from the outside? I can't. I'm failing at one of my fundamental missions. How can I get to a fire that's in an attic space that doesn't have windows from the outside? I can't. I'm just waiting for the building to burn down. We are not a demolition company. We are firefighters. That's what we're here to do. And we didn't cause the problem, so we shouldn't become part of it. This is one of the most frustrating points to me. That is correct. We did not cause the problem, but we signed up to be part of it. We signed up to stop the problem. And yes, sometimes that involves danger and threats to our own lives and our own safety. But we're going to talk about how we can control that. We're going to talk about a third avenue here. What I'm advocating for is a modern firefighting for modern buildings. Let's start off with two facts that I hope we all agree with after watching this presentation. Lightweight construction does change the firefighting environment. Lightweight construction is not the old school construction. It is different, and it has to be treated as such. Interior fire attacks are the most effective means to extinguish a fire and search. As I just discussed, I can't find people from the outside. I can't get to the seat of the fire from the outside. If I put water directly on the seat of the fire, I stop the burning, I stop the damage faster. So what should we do? Lightweight construction has benefits for us, and we should use them. Yes, there are a lot of bad things about lightweight construction to the fire service, a significant amount of them. But one of the best things about it is compartmentalization. We keep the fire in one space. One of the things that we all forget about in the fire service is that buildings are not bare. You don't see the walls in your house. Drywall's on top of it. Plaster and lath is on top of it. There are things that we call interior finish that prevent fire from accessing those areas. Yes, a fire impinging on the structural elements could cause a floor to collapse in 4 to 6 minutes, but drywall has a fire barrier time of 30 minutes. If there is not an immediate opening, drywall will hold fire for 30 minutes. Now, that's not all the time. There are openings in all of your houses. There's outlets. there's ceilings, there's lights, there's ventilation. There are ways that the fire will work around, but it doesn't mean 4 minutes after the fire starts, our floors are going to collapse. It means that somewhere between 4 and 36 minutes after the fire starts, the floor is going to collapse. So let's use the benefits. Closed doors prevent ventilation, sealed passageways for fire to move, allowing us to get to the fire without it spreading. Lightweight construction isn't unpredictable, it's fast acting. Lightweight construction is just as predictable as old construction. One of the glories of the fire service is that it's all science. If I could take the building and take the fire and replicate those perfect scenarios into a computer, that computer will predict exactly what happened 100% of the time because it's all science. It's all physics. Lightweight construction isn't magic hoodoo or voodoo that gives away when people are standing on top of it. It is absolutely just very fast acting science. We don't get the warning signs anymore. We have to train to recognize the problems very quickly. Because in the past, you had a little time. The building's groaning, you had a second to think, that's bad, we should leave. Lightweight construction, you set your foot on the floor sags. You need to know not to continue setting your weight on that because it's going to go. We have to train. We have to know these things, and we have to know them at the snap of our fingers under high stress situations when we're thinking about 100 different things. These have to be the things that we eat, sleep, and breathe because they will kill us if we don't. But if we do, we will save people. So the three things we need to do, we need to train. We need to know these buildings. We need to know how they react under fire. We need to know how they warn us they're coming down. We need to identify. You can train till the cows come home. If you don't open your eyes, it won't make a difference. Pay attention. Sound floors. Know what you're listening for and listen for it. And we need to operate. We need to operate in a quick, efficient, aggressive manner that understands the dangers that face us, that understands how the building will now react because of the construction style, that understands the tactics we can use to oppose the things that the building is trying to do, that the fire is trying to do. That's how we bring modern firefighting into modern buildings. These are my citations I used for all of the pictures above.